I am Dr. R. Muthukumaraswamy, Professor and Head, Department of Applied Mathematics. Now I am going to explain even and odd function and how to evaluate the integrals using even and odd function and how we are going to reduce and in Fourier series even and odd function. Explain the concept of even function, how to apply in integrals. For example, you know the properties of definite integral minus a to plus a f of x dx is a property is twice 0 to a f of x dx if f of x is even. If the function is even, then I can write like this. Otherwise, f of x is odd. That means if it is 0, the function is odd. This is a property of definite integral. We'll recall, you take some even function. For example, minus 1 to 1, I am integrating x square dx. You know very well this is even function. So normal integration x cube by 3 minus 1 to 1. If I substitute 1 by 3 minus of minus 1 cube by 3, you will get 2 by 3, right? When I apply properties of the integral, I can write immediately twice 0 to 1, that is minus 1 to 1. So if I take the interval minus 1 to 1, midpoint 0, so I am going to take entire range. I am not ignoring entire range. I am taking only the positive range. If I double the positive range, you will get the negative side. So while applying the function even, you know the property of even function f of x equal to f of minus x. Negative as well as positive remains unchanged. So whatever the negative value is copied as it is, so you will get twice positive value alone x square dx. If integrate, you will get, of course, x cube by 3, 0 to 1, you will get 2 by 3, lower limit 0. Now, you know very well these two are, this is direct integration, I am using property. Similarly, for odd function, if you take a function is odd, then f of x equal to minus of f of minus x. Let us take very simple example, minus 1 to 1, or you take minus a to a, no problem. You take x dx, right? When you integrate, you will get x square by 2 minus a to a square by 2 minus a square by 2. You know very well 0. So by default, as long as my function is odd, I am not going to integrate straight away. I can put 0 according to the property. So I don't want to elaborate. Just if it is minus a to a, the function is odd. No need to integrate. The value by default 0. This is mathematically proved, the conventional. So this is what these two basic fundamentals we are going to apply in Fourier series. Okay. Let us take the Fourier series f of x. I am taking any one of the combination. The function I am going to define in the interval minus pi to pi. Let us take the function mod x in the interval minus pi to pi. How I am going to justify this is an even function. So remember, when we apply even and odd function, the limits should be minus a to plus a. So that is very important, minus a to plus a. Then only I can apply this property. Otherwise, do not apply. Suppose the limit 0 to 2 pi, do not apply this property. That is not correct. It should be minus a to plus a. It's spread out negative to positive range. Okay, let us take this one. You know how to represent a modulus function. Very simple graph. It's like V-shaped graph. This is y-axis, x-axis, y is mod x. This function is x and this is minus x. Okay, I am taking some periodic length minus pi to pi. Okay. So here all positive values of x, my function is x. Okay. That means positive value means 0 to pi. the function is positive in the interval 0 to pi. If it is negative, that is minus x, in the interval, how to write? You have to write, okay, minus pi less than x less than 0. Remember, you always end up with the maximum value at the end, the lowest value, least value, the lower limit. So that is the way you have to arrange. So this is the way we are splitting up the function. Now we are going to check whether it is odd or even. So I am taking first combination even function. Okay. Now let us take a function. Suppose the problem is given to you like this. First of all, you have to divide the interval into two different positive and negative combination. Let us take, that is your choice. I am taking a positive function. Okay. I am taking a positive function x. Just replace minus x. If I replace minus x, I will get minus x. No doubt about this. You will get automatically the other side of the function. So this function is clubbed into a single interval minus pi to pi. The problem is you have to divide the function into positive and negative range, and then you have to analyze. You take either negative range or positive. That is your choice. Normally we start with positive side. You choose function defined in the positive side. Take the function x, replace minus x. You will get automatically the other side of the function. Therefore, my f of x is even. Okay. I am going to explain the concept of Fourier series and what is the role in even and odd function. So what is the advantage of using even and odd function in Fourier series? Instead of doing all the Fourier coefficient, if the function is even, my focus only on the even function. So you know constant is an even function, cosine is an even function. That means this is an odd function. So definitely this is going to be 0. How we are going to justify? Let us take what is a naught. You know the formula 1 by L, in terms of pi, 1 by pi C2 C plus 2 pi f of x dx. Okay, this is 1 by pi f of x. Suppose the function defined in the interval C2 C plus 2 pi. That is my interest. Suppose I am taking the interval minus pi to pi. Why? Because my focus on even function defined in a particular case minus pi to pi. Now I am going to substitute 1 by pi minus pi to pi, okay, f of x dx. If my function is even, if the function is even, according to the property minus a to a, f of x dx, the function is even, then you know 2 by pi of the positive range. So this is what my a naught. If my function is even. Okay. Same way, let us take an. 1 by pi integral c to c plus 2 pi f of x cos nx dx. So I'll recall just fundamentals, you know very well. This function I am assuming even. I enclose the bracket. This function well known, cosine by default even. Even into even. Even function. Okay. So my focus on this. So let us take minus pi to pi. So f of x cos nx dx. So I am substituting the particular case. Now only you have to analyze. Yes, this is even function. This is also an even function. Even into even, even. Therefore the entire integrand is even. If the integrand is even, I can apply the property. So 2 by pi integral 0 to pi f of x cos nx dx. So this is my an. Okay, next let us take bn. 1 by pi integral c to c plus 2 pi f of x sin nx dx. If I take this way, sin nx dx, if my function is even in the interval minus pi to pi, my function is even. Okay, You know very well this is odd. Even into odd, odd. If the integrand completely odd, you know very well the product of even and odd over minus it. So 0. That means your Bn is 0. So what happened your Fourier series? By default, if the function is even, you will get only these two terms and these two have to evaluate. So no need to evaluate Bn. So that's a major advantage of using the properties of even and odd function. Now I'm going to explain the concept of odd function using the same combination. If my function is odd, okay, let us take the Fourier series f of x equal to a naught by 2, more general Fourier series, n equal to 1 to infinity, an cos nx bn sin nx. Okay, so what is a naught? 1 by pi integral c to c plus 2 pi f of x dx. If I set the limit minus pi to pi and my function is odd, if my function is odd, you know the value of the integral 0. Same way an 1 by pi c to c plus 2 pi f of x cos nx dx. So definition. Let us substitute the limit minus pi to pi f of x cos nx dx. If the function here odd, that is we are going to take cosine is an even function, odd into even, entire thing is odd, the value of the integral 0. Now very interesting, a naught and an totally collapsed, c to c plus 2 pi f of x sin nx dx. Okay, so let us take the range minus pi to pi f of x sin nx dx. So here the function is odd, sin is also odd, odd into odd, even. So the entire integrand is even. Then I can write twice 0 to pi f of x sin nx dx. So for Bn the value exists. So what happened? An and a naught completely 0. So these two are completely 0. You will get only this term. So therefore f of x equal to sigma n equal to 1 to infinity Bn sin nx, where Bn is this. So if it is odd function, our job is very simple, only a single integral. That's a major advantage. Majority of the odd, this property is going to be repeated in the boundary value problem. So I'll recall finally entire thing in a simple form, how to summarize for all these combinations. Let us take the more general case. Yes, this is more general case. If my function is even, the Fourier series function is defined, I have checked this, then I can write immediately only cosine term by ignoring the sine term. Just write from this, no need to mug up separately. And a naught, remember, while evaluating even function, it should be even number first. Okay, 2 by pi 0 to pi f of x dx. An 2 by pi 0 to pi f of x cos nx. Only these two exist. By default Bn is 0, no need to write, just ignore. Similarly odd function, you take only the sine term, ignore these two, sigma n equal to 1 to infinity Bn sin nx, ignore these two. So very simple. And what is Bn? You know, I have already explained how this is deduced by taking minus pi to pi. So the extract of what we have done so far, these two are very important concept for solving problem. Forget about the bookwork behind this, is only for understanding. Similarly, for change of interval, take the change of interval. That means you take the general Fourier series. So this is more general Fourier series. A function defined minus L to L. Same way, just ignore Bn, write these two. and instead of pi I am replacing L 2 by L 0 to pi f of x dx. Actually this is more general form. If I give L equal to pi, you will get back the previous one, of course. So just recall this more general form. Then wherever L, if you put pi, you will get back what we have done so far, the previous example. Yes, wherever L you replace pi, you will get this. So no need to bug up separately. If you know the more general form, that's more than sufficient. Thank you. Now I am going to explain with a different example f of x equal to cos ax in the interval minus pi to pi. The total range is of course 2 pi, is a periodic function, not always 0 to 2 pi, sometime minus pi to pi. Okay, what type of function? Cos. Cos is an even function. So no need to check, straight away you know cos of minus theta is cos theta. Okay, let us take the next example. Okay, the function defined like this. How we are going to check whether it is even or odd? Let us take the function defined in the positive side. Yeah, 1 minus 2x by pi. Function defined in the positive side. Replace minus x. You will get 1 plus 2x by pi. Take the positive off of the interval. I am replacing negative symbol. I will get back the other side. So therefore f of x is even. Okay, next let us take the function f of x equal to x minus x cube in the interval minus 1 less than x less than 1 for it. Either in terms of minus pi to pi or constant limits, no problem. This is a more general form, change of interval or more general form. The range is 12. That is the way we are going to take. So this function is odd. This is also an odd function. Odd minus odd, so odd function. We can cross verify. Let us put negative symbol. So minus x minus minus x cube. So we'll get minus x plus x cube. Take it out, minus symbol, x minus x cube. So f of minus x turns to be positive. Therefore f of x equal to f of minus x is odd function. Okay, now how we are going to substitute in Fourier series, we will analyze in detail.